Hi everybody, my name is Ben Rudin and welcome to my Leetcode series. So in this series we're really just going to be going through some Leetcode problems. I'm going to give you solutions that I come up with, or maybe I have multiple solutions and we can talk through different ones. And I think this is a good way for me to obviously learn, being able to explain to other people. So this is a fun problem that I actually just finished a little bit ago, and it is a medium problem. So maybe a little more difficult than some of the Leetcode problems out there. So let's go ahead and talk through the prompt a little bit. So you want to water n plants in your garden with a watering can. The plants are arranged in a row and are labeled from 0 to n-1 from left to right, where the ith plant is located at x equals 1. And there is a river at x equals -1 that you can refill your watering can at. So each plant needs a specific amount of water, and you will water the plants the following way. So we'll water the plants from left to right. After watering the current plant, if we don't have enough water for the next plant, we need to go refill at the river. And you cannot refill the watering can early. So we need to go as far as we can before refilling. So we start at x equals -1, and it will take one step to move 1 unit. So we can consider that one index position as 1 unit. So we're given a 0 indexed array, and we need to return the total number of steps that we step to solve the problem, to water all the plants. So I'm going to talk you through this first example, and then we're going to talk about my solution here, and I'll go ahead and delete this for now. We'll code that up together. So let's go ahead and pull up a little bit of Notepad that I prepared. So our first example, we have an array. We have 4 plants, as you can see, a size of 4, and the plants require 2, 2, 3, and 3 units of water. The capacity of our watering can is 5 units. So the river, again, is at index position -1. So just to see our plants versus our index, we have 2 at 0, 2 at 1, 3 at 2, 3 at 3. Okay. So let's go ahead and talk through the kind of the pseudocode of this problem. And I think the most basic approach here would be to use a for loop, obviously. So we'll say at iteration I equals 0, we need to check at each iteration, is our watering can amount greater or equal than our plant amount? And if that's a yes, we can continue. We go ahead and water the plant. We'll subtract the units used out of our capacity, and we'll count that as 1 total step. So in this case, we start with 5 capacity in our watering can. Plant 1 needs 2 units of water, so we can continue. We need to subtract those 2 units of water, so we have 3 left after watering the plant. That takes 1 total step. So the same thing is going to repeat for iteration I of 1. In this case, we now have 3 units in our watering can. We need 2. So yeah, we can continue. That's greater or equal than 2. And we need to go ahead and subtract the units used that we just watered the plant with. So we'll have 1 unit left of water in our watering can. That takes 1 total step for iteration I equals 1. Now at I equals 2, things change a little bit, because we first need to check, can our watering can, does it have the current amount needed to water the next plant? And in this case, it's no. We only have 1 unit of water in our watering can, and our current plant needs 2 units of water. It actually needs 3, excuse me. Say 3 there. And so when we go through this, remember, we're technically standing at I minus 1 because we're checking the next plant. So for I equals 2, we're currently standing at I equals 1, and we're checking plant I equals 2. Like, do we have enough? If so, we step to that plant. If not, we go back to the river. So we're standing I equals -1, and at I, we're just checking if we have enough water to fill the plant at I. Thus, in this case, we don't. We need to go back to the river at -1. That will take I steps, because in this case, we'll go from 1 to 0, 1 step back, 0 to -1, 1 step back. That gets us to the river, and that's 2 total steps. So we refill our capacity of 5. Now we have to get back to plant I. Now we know we need to step all the way. So this will take I plus 1 steps, because we're going -1 to 0, 0 to 1, 1 to 2, and this will take I plus 1. In this case, it's 3 total steps. We go ahead and subtract our unit here, just like we did in the first few steps. And that is going to take us to 5 total steps in this iteration, because we had to get to the river, that was 2. You had to get to the next plant, that was 3. So now we go to our next iteration, I equals 3, our last plant in the array. And again, we check, so is 2 greater or equal than 3? No, it's not. So we repeat the whole process. We go back to the river, which takes I steps. Then we go back to the current plant, which takes I plus 1 steps. And in this case, we will have 3 plus 4 equals 7 steps total. Then we need to add up the rest of our steps here. First iteration was 1, second iteration was 1, I equals 2 iteration was 5, I equals 3 iteration was 7, 14 total steps used in this problem. So let's go ahead and code up a solution very quickly. So I'm going to start with int c equals 0. That's going to be our counter for our steps. I'm going to say int cap equals capacity because we need to be able to reset capacity. So I can't just take the capacity variable and update it. I need to be able to manipulate it. So we'll make a new variable here. Now we're going to have our for loop, plants.length, I++. So we can say if plants cap is greater or equal than plants I. In that case, I just iterate my step counter. That's all I have to do, and we'll update our watering can capacity at the end. Else, I can say C plus equals I plus 1. Because remember, we determined getting back to the river is I, getting back to the plant is I plus 1. So that's all we need to do there. And then in both cases, we can go ahead and update our capacity at the end. So what's going to happen here is we'll say cap minus equals plants I. And actually under this too, I need to reset my capacity. So I'll say cap equals capacity. Because in the else statement refers to when cap is not equal or greater than plants I. So, and at the end, we can just return C. Let's go ahead and run the code for the test cases. And as you can see, that will come back successfully. And going to my submissions, this same code got you this. Obviously, this is device dependent, but it should run pretty well for you. So that's my solution, a very easy, straightforward approach, and I hope you were able to understand the problem from my explanation.